Alright, welcome back to the next type of graph. So we discussed the polynomial graphs and we discussed the exponential log graphs, right? The last kind of graphs that you can expect to always encounter is this thing called a rational function. And what a rational function is basically is just algebraic function, usually in the form of a fraction. So for example, I have y equals to x minus 1, x plus 2, right? Example, or like y equals to x squared over x minus 1, right? Or even like y equals to x cubed minus 1 over x squared plus 1, right? Examples like that. So these are all just examples. So the criterias, again, are these four. And when it comes to graphs of rational functions, all these four can have their own place, right? You have restrictions, intercepts, stationary points, asymptotes. So rational functions you need to be very careful when you actually sketch it, right? Make sure you include all four of them if they are present. So I'll show you an example now using this over here, and then you will try it out for yourself for the next portion over here. Okay, so the first one, we actually have y equals to 5 minus 3x and x minus 3. So I'm going to show you how to use like working to predict what are the asymptotes first, and then I will show you how to use the GC to actually sketch it. So if you want a very, very complete answer, right, that literally guarantees all the marks in the exam, it's good to also show your working. How do you actually derive the asymptotes and all that? So y equals to 5 minus 3x over x minus 3, right? First thing is my XL-intercepts. So, or rather, yeah, my XL-intercepts. So my x-intercept, y-intercept, right? So when x equals to 0, right, I get that y equals to 5 minus 0 over 0 minus 3. I get negative 5 over 3. So I know that I have 0, negative 5 over 3 as one of the points. When y is 0, I get that 0 is 5 minus 3x over x minus 3. So from here, I get that 5 minus 3x must be 0. And therefore, I get that 3x is 5 and x equals to 5 over 3. So over here, I get the next one, which is 5 over 3, 0, right? Now, next would be my asymptotes. So this over here is currently improper because the degree is 1. The degree is 1. So I do long division first. So y equals to 5 minus 3x over x minus 3. I divide negative 3x plus 5, x minus 3, minus 3. Then here would be minus 3x plus 9 minus 4. So this can be written as minus 3 minus 4 over x minus 3, right? So for this portion over here, when x approaches 3, right, this whole thing will become 0 and my y will approach plus minus infinity. So I know that x is 3 is my vertical asymptote. That's number one. Next, when x approaches plus minus infinity, my whole fraction over here will approach 0. And as a result, my whole y value will actually approach negative 3. So y equals to negative 3 is my horizontal asymptote. Okay, and yeah, that's about it. Now, there's no oblique asymptote because we can clearly tell that there's no oblique asymptote. If there was an oblique asymptote, there will be something mx plus c over here, but it's just negative 3, so therefore it's just a horizontal asymptote. Okay, so that's it. Now, for this graph over here, there's no stationary point because we can tell that it's a reciprocal graph. Later I'll show you when I sketch it out on the GC, but since it's a reciprocal graph, from here we can tell, we can predict that there is no turning slash stationary point. Okay, so now I got the working done. I'm just going to show you how it looks like on the graph when I sketch it. So I'm just going to go back to the GC here, and then here I will clear, enter. 5 minus 3x, x minus 3, and graph it out. It looks like that, right? So if I were to sketch this out, this is y, this is x, then I can see that here it goes from the bottom to the top, bottom, top, like that, and then another one, it goes from the bottom and it flat lines. So you see here is my horizontal asymptote of y equals to negative 3, right? You can see that here is my horizontal asymptote, y equals to negative 3, and then here is my vertical asymptote, so I just need to redraw this here. My vertical asymptote of x equals to 3, and then my XL-intercepts. Right, so what are my XL-intercepts? My XL-intercepts here, this one would be my negative, no, it should be my XL-intercept. So this is 0, negative 5 over 3, right? This is my y-intercept, and then my x-intercept is here, right? So this is 5 over 3, 0, which is what we have calculated so far, right? So we have calculated all of this, and true enough, this is how the graph actually looks like. Okay, so actually the process is very, very similar to all the previous examples. So by now, I hope that this is not too difficult for you. All right, so if not, feel free to pause this video right now to attempt this and come back when you are ready and we'll go through the answer together. Okay, so let's go through this together now. Sketching this graph, again, we are going to be using your GC, but before that, let's reduce this to a proper fraction so that we can write down the working, right? So long division, x plus 1, x minus 2, divide 1, x minus 2, and then here end up with 3. So this can be written as 1 plus 3 over x minus 2. So we can see that for this graph, right, what are the XL-intercepts first? So when x equals to 0, y equals to 1 plus 3 over negative 2, right? Which gives me negative half. So 0 comma negative half is the first y-intercept, right? Y-intercept. Next, when y equals to 0, I get that my equation is 0 equals to x plus 1 over x minus 2. So x plus 1 is 0, and therefore x is minus 1. So the x-intercept would be negative 1 comma 0 over here, right? So the first two important things. Next are all my asymptotes. So when x approaches 2, I see that y actually approaches plus minus infinity because the denominator here will become undefined. So therefore, I know that x equals to 2 is the vertical asymptote. Next, when x approaches plus minus infinity, I get that y will approach 1, right? Because this whole fraction will become almost 0, and then what's left is just 1. So I get that y equals to 1 is left. So overall, when I sketch this graph, right, using my GC, if you plot this in your GC, you'll realize that the shape looks something like this, right? You get that the shape looks something like this, and then, oops, let me just draw it a bit more accurately. You get that the shape looks something like this, and it looks something like this. Where you over here, you have a asymptote. So this is my x equals to 2 asymptote, and then here is my y equals to 1 asymptote. And then if you were to plot the two intercepts, this one would be negative 1 comma 0, right, xy, and then this one over here would be 0 negative half, right? This one would be the other intercept. So this one will be 0 negative half. And all in all, this is how the graph is actually look like. Okay, so with that said, we have come to the end of graph sketching for rational functions, and this concludes the first part of this chapter. Let me know if you've got any other questions. If not, I look forward to seeing you in the next part of this chapter.